Exploring the elements of the world, unveiling the mysteries of nature. When we look around us, we see a world filled with a variety of elements that make up the building blocks of our environment. From the oxygen we breathe to the water we drink, each element plays a crucial role in sustaining life on Earth. The exploration and study of these elements have been a fundamental aspect of scientific research for centuries, shedding light on the mysteries of nature and guiding advancements in various fields. Understanding the composition of the universe. One of the key objectives of exploring the elements of the world is to unravel the composition of the universe. Scientists have long been intrigued by the origins of elements and how they have shaped the cosmos. By studying the distribution of elements in stars, galaxies, and planetary bodies, researchers have been able to piece together the story of the universe's evolution, from the Big Bang to the formation of complex molecules. Investigating the properties of elements. Each element in the periodic table possesses unique properties that define its behavior and interactions with other elements. Through experimentation and observation, scientists have been able to uncover the physical, chemical, and nuclear properties of elements, paving the way for groundbreaking discoveries. For example, the discovery of noble gases led to the development of technologies such as neon lights and helium balloons, demonstrating the practical applications of elemental research. Charting the course of elemental reactions. Chemical reactions are at the core of many natural processes, from photosynthesis in plants to the combustion of fuels. By studying the mechanisms behind these reactions, scientists can gain insights into the fundamental principles that govern the behavior of elements. This knowledge not only deepens our understanding of the natural world but also has implications for areas such as drug development, environmental remediation, and materials science. Unleashing the power of elemental innovation. The exploration of elements has led to numerous innovations that have revolutionized industries and improved the quality of life for people worldwide. From the development of semiconductor materials for electronics to the discovery of new elements in the periodic table, elemental research continues to drive progress in science and technology. By harnessing the power of elements, researchers have unlocked new possibilities for addressing challenges such as energy sustainability, healthcare, and environmental conservation. In conclusion, the exploration of the elements of the world is a timeless pursuit that has enriched our understanding of nature and propelled human civilization forward. As we continue to delve into the mysteries of the elements, we unlock new horizons of knowledge and innovation, shaping the world we live in and paving the way for a brighter future. Exploring the elements of the world, a comprehensive study. The exploration and study of the elements of the world have been a fundamental part of human civilization for centuries. From the ancient Greeks to modern scientists, the quest to understand the building blocks of our world has driven discovery and innovation. In this article, we will delve into the importance of exploring the elements and highlight some key findings from recent research in this field. The periodic table, first developed in the 19th century, is a comprehensive framework for organizing the elements based on their atomic structure and properties. This table, which now includes 118 known elements, serves as a roadmap for scientists to explore and understand the fundamental components of matter. It has also been instrumental in guiding the search for new elements and understanding their potential applications. One of the most significant areas of exploration in the study of elements is the discovery of new elements. Over the past few decades, scientists have successfully synthesized several new elements, expanding the periodic table and pushing the boundaries of our understanding of atomic structure. For example, the discovery of elements 113, 115, 117, and 118 in the past few years has opened up new avenues for research and development in the field of nuclear physics and chemistry. Furthermore, the study of elements has also revealed important insights into the behavior and properties of matter. For instance, the discovery and characterization of superheavy elements have provided valuable information about the stability and longevity of nuclear structures, shedding light on the fundamental forces that govern the universe. Additionally, research on transitional metals and rare earth elements has led to the development of new materials with unique properties and applications in various industries. Moreover, exploring the elements of the world has practical implications for our daily lives. Elements such as carbon, hydrogen, oxygen, and nitrogen are essential for life as we know it, and understanding their role in biological processes is crucial for advancing medicine and biotechnology. Elements like silicon, lithium, and copper are integral to the development of modern technology, from semiconductors to batteries to electrical wiring. In conclusion, the study of the elements of the world is a vital and ongoing endeavor that has far-reaching implications for science, technology, and society. As we continue to explore and understand the fundamental components of matter, we open up new possibilities for innovation and discovery. The periodic table serves as a roadmap for this exploration, guiding scientists to new frontiers in the quest to unravel the mysteries of the universe. With each new discovery and breakthrough, our understanding of the elements deepens, paving the way for a brighter future. Investigating elements. Introduction. Planet Earth and everything living on it is made up of elements. An element is a pure substance made up of atoms all of the same type. Some elements are vital to our survival, while others, depending on the dose, are harmful to us. Globe showing global grassland coverage, focus on Australia. Rights. NASA Goddard Space Flight Center Scientific Visualization Studio. Earth from space. Planet Earth and everything living on it are made up of elements. The origin of the elements is very much a cosmic affair. So where did elements come from? How are elements classified? What uses have we found for elements in our modern society? These resources may be able to provide answers to these questions. Where did elements come from? Here's what Martin Rees, UK's Astronomer Royal, recently said. And we know that every atom in our body was forged in an ancient star somewhere in the Milky Way. We are literally the ashes of long-dead stars, the nuclear waste from the fuel that makes stars shine. To understand ourselves, we must understand the atoms we're made of, but we must also understand the stars that made those atoms. The experiments conducted at the Large Hadron Collider at CERN in Switzerland allow scientists to better understand the fine structure of atoms and explore the conditions that are thought to have existed at the moment of creation of the universe. Universal element formation. Elements are formed deep within the cores of certain types of star. Find out more in this interactive. Arranging the elements. The periodic table of elements is a very useful tool, and it can be used to organize many of the ideas in chemistry. The development of the periodic table is a fascinating story, demonstrating the roles that imagination and creativity play in science. The search for new elements continues at many research labs around the world. Use the Large Hadron Collider particle physics research conducted by Dr. David Krawczyk as the context for learning about how elements are formed and the structure of the nucleus. There are several student activities associated with the elements. Create a photographic periodic table. In this activity, students collect images of everyday objects to represent the elements in the periodic table. Element wrap. In this activity, students become familiar with the names and symbols of the chemical elements by creating a rap or poem. Symbol find. In this activity, students become familiar with symbols of the chemical elements by creating them using letters from a phrase or sentence. Atomic clock. Use this teacher resource to familiarize students with the names and symbols of the chemical elements. Elements reacting with oxygen. In this activity, students investigate the reaction between copper and oxygen and watch a demonstration of the rapid reaction between hydrogen and oxygen. The article Elements, Weird and Wonderful is a light-hearted look at a few of the elements, some we use every day and some that barely exist. Essential elements. Which elements are we humans made up of? Does our diet provide us with all the elements we need? What happens if we have too much or too little of a given element? The article The Essential Elements provides answers to these intriguing questions. Tube of iodine in a beaker showing purple color of its vapor. Writes Pierre Joliveau. The element iodine. Iodine, a solid at room temperature, is element number 53 on the periodic table. When gently heated it sublimes into a purple vapor as seen here. Iodine is an essential element in the diet. Too little can result in the medical condition goiter. Using iodized salt is one way of making it available to the body. Uses of metals. Of the 92 naturally occurring elements, 78 are metals. Our modern society is literally built with metals. But forget iron and aluminium. Titanium is the metal of the future, with titanium alloys increasingly being used in transport, medical science and high-tech sports. Dr. Brian Gabitas and Professor Deliang Zhang are two of the scientists involved with the production of titanium-based alloys. Read about the properties of metals, alloys and metal compounds, then use plasticine and sand to make model alloys. Titanium ring on white background illustration. Writes The University of Waikato Te Warawaninga o Waikato. Titanium ring. Titanium has some unique properties. It is lightweight, very strong and tough, corrosion resistant and, unlike most other common metals, does not feel cold to the touch. This ring was crafted out of a solid piece of titanium, unlike conventional metal rings that are formed by joining the ends of a piece of metal by soldering or welding. Isotopes. Most elements consist of atoms having several different mass numbers. Atoms with the same atomic number but a different mass number are called isotopes. Isotopes, particularly those that are radioactive, are widely used in our modern society. Perhaps the best known of these is carbon-14, which was used by Dr. Fiona Pecci to date artifacts of historical importance in an archaeological dig at the Wairau Bar close to the town of Blenheim. Isotopes are used for more than carbon dating as explained in the articles Radioisotopes and Using Isotopes as Tracers. The student activity Radioactive Decay uses coin flips to explore the concepts of half-life and the randomness of radioactive decay. Question Bank. The Investigating Elements. Question Bank provides a list of questions about ceramics and places where their answers can be found. The questions support an inquiry approach. For explanations of key concepts, see Investigating Elements, Key Terms. Explore the timeline to look at some of the early discoveries about the metal titanium. Te Taka Pumotu, the Periodic Table of Elements. Te Taka Pumotu, the Periodic Table of Elements lists the atomic number Tua Iraho, atomic mass, Tau Karihi, element symbol Tohu, English names Kupu Ingarihi, and Maori names Kupu Maori for the first 103 elements.